thinking some stuff through, you know, like I need a second. I gotta soak it in and have to forget about it. So it was at 13.44, it's at 13.4. Lithiums, you know, they stay at the same voltage. So it's not gonna be like a lead acid battery where it goes up and then it goes back down, you know, and you can really tell this is going to stay at the same voltage. It's going to be almost no way to know if this is taking something out of the battery. So I don't know, I'm gonna let it sit here and run for a minute. I don't know how much fuel we got left. Okay, yeah, 13.39 dropped. Eventually, I guess when it drops below a certain, I may have to increase the voltage. This does have an app. I'm going to see if I can finally Bluetooth to it, or what do I need to do. I may have to revisit this tomorrow or the next day once I get, you know, this thing mounted inside the boat. She's a smoker. Well, it's a new week, new set of projects, and thanks for watching. Well, it's a new year, it's a new week, new set of projects. I got this cool little runabout I've been working on. Surfside, Elmore, Alabama. It's got a me top. Little ladder, and I just put new LED lights on there that he ordered for his trailer. This is a Johnson 65 Powershift 2 65 ESL 73 1973. So I don't know, there's some videos on this already. Put new hose line to his tank. I need to go get some gas. I need to make some list of stuff I need to go do. So I need gas. We're gonna put some hub buddies on it. So I need to go over to my dealer or whatever and grab those. And then he wants to be able, because he hates flooded batteries. So he's already taken his out. I need to clean this up. He wants to convert this because he saw Born Again Boating's video about the Victron Electronics. They make a DC to DC converter, which allows you to run a lithium battery on an older outboard. So I don't know if anybody's ever done one of these, but I'm gonna try to show you what's happening. So basically, you know, as I understand it, okay, we have our outboard, right? So on any outboard, we got two circuits. We got one that's a starting circuit. You know, it triggers a solenoid through a signal wire, which sends the amperage voltage to the starter, cranks the engine. Then we've got another system, which is the charging system, and that's typically tied to your battery. It's the stator that's under the flywheel, and then it sends an AC voltage and current to a rectifier, which then in turn rectifies the voltage so that then it's DC voltage and it goes back to your battery and charges the battery. And like an ADI system, you know, it's alternator driven ignition. So you know, some of these tie back, to make this simple, some of these tie back to the battery. In older systems, like, the battery basically becomes the voltage regulator. So then they became, like with modern systems, they had a voltage regulator, and that was tied to usually a flooded battery. And that flooded battery, you know, when it would stop charging it once the battery became fully charged. So the charging curve would show, you know, was designed right for flooded batteries because their reaction time was a specific, you know, wave, if you will. It had a specific curve. So as they develop batteries, and I'm just spilling this, man, I don't even know, you guys probably correct me on a bunch of this stuff, but basically AGM had a different curve, but still it was designed so that, you know, it could still be within the flooded battery curve. So like on boats, normally, like, your best battery choice up until now has been an AGM, because it can deliver a lot stronger, you know, current and voltage spikes than a flooded battery. So they designed it so that it was actually an improvement, because they were like, well, it's going to cost more money. Most people aren't going to go out and get it if it wasn't better. So it is better. And I can tell you, like, on the Alumacraft over there, that battery is, you know, you can tell when you're cranking it. Like, especially if I have to crank an engine for a long time, you know, usually flooded, I got to charge it up. Even if it's a lot of cranking apps, the AGM absorbs that better. Okay, so now we're into lithium. So all the new guys with the 4 strokes, you know, above a certain year, they had alternators, which is basically still what a stator is, that had voltage regulators that could put out the curve, the right curve to charge a lithium. And so all the guys that were running older outboards, they couldn't do anything, because it would either blow up your stator or it would blow up your battery. Not blow it up, but they would just stop working. So that's not a solution at all. You know, you don't want to use a lithium battery. That's why everybody has said, you can't use lithium until now. Well, until I first heard about it. I'm sure it's been out for a while, but I didn't know about it. So, you know, kudos to the born again boating guy. And now the only thing is like, I was looking at the one that he had on this video, because I watched it, and he had a non-isolated version of the Victron. It's what is it, orion-tr Smart 1212, and you can get them, you know, 30 amps, 50 amps, you can get them 24 volts, you know, but it's their Smart series, and it's a DC to DC, you know, basically charger. So it looks at the outboard's charging circuit and sees a specific range or resistance, and it knows that those range and ranges are not the same because the lithium battery. So what it does is equalize that and then charges your lithium battery, and it's pretty smart. So like, it has Bluetooth technology, And then they also made it so that with a key on switch, you could isolate your alternators, everything. So that's why I chose to go with a non-isolated unit. Everything becomes the grounds, or basically the water. So in my case, I wanted to separate the outboard from, say, pumps and lights on your boat. What we're going to do is we're going to adapt this thing to run a lithium battery on a 1973 engine. That's pretty cool. Now, I'll just tell you, it's expensive. Most people aren't going to do this, but there's some people that want to. They're like, oh yeah, you know. So as lithium batteries come lower and lower, then all you got to do is add a little technology, and then suddenly you can run lithiums for. That's a thing, like on a boat, a cranking battery, now they have lithium dual purpose cranking batteries, and they'll crank your engine and then they'll act like a deep cycle. And so you could literally have all kinds of lights on, and you're gonna have like a pretty long run time. Now he's got the old Powershift 2 remote. It's got a key that's stuck in the ignition. And I told him just leave it. But I guess he was, he's going to have it sitting up, parked in a parking lot, so he may not want to do that. I don't know. Yeah, he's already got a couple new seats, but this is, yeah. Anyway, it won't come out. Okay, I kind of had it out of the box, but this is it. Isolated DC to DC converter. Orion-tr, so it's a TR Smart. Alright, so these are our input outputs, and this is like our signal. And so I already had it out, and I was thinking about this because this is the first one I've ever done. And so I went ahead in order to connect these. And this is just these, rated up to like 30 amps. I have to look up the specs on it, and then in the manual, it called for these 50 amp fuses on the battery, and then this is the isolated DC converter. So my original thought was, well, everything what they have in diagrams shows, the engine connected here and then the battery connected here, but you can see that like this is not very big, right? And so my first thought was, well, like, how are you going to put like a 6 gauge or an 8 gauge wire in there? And then that's going to heat up and corrode. That doesn't seem right to me. And the more I got to thinking about it, it's like, wait a minute, we got two different circuits really that we need to be concerned about. Now right here, if you notice, it says remote. And what that is they give you this this little piece right here, and what it does is detects, like with a key, when it goes to the on position, typically like, your purple wire goes to your gauges, and that provides power, okay? And so once it sees this power, and I'm going to have to look at the directions because, we got to figure out if it's they want to see like ground, or they want to see 12 volts come in. Is it ground controlled, or is it positively controlled? I don't know. It costs like $215 for this unit. And then he brought me a battery, because I was looking at like what I carry is the Epoch, but there's so many people making lithium batteries now. You know, I'm like a dealer for Ionic and all kinds of people, but he had this battery. This battery right here, and it's a, you know, Bluetooth auto heating, so it stays warm, dual purpose, group 27. Yeah, anyway, this looks like a really good red Odo, so I'll have to look into redodopower.com. Here's another one that's a Dr. Prepare. These are super cheap, but these are not a cranking battery, so you couldn't use these because it's not got that curve. So they got this that goes in there, and it's little set screws. So why I'm showing you that, it's got a remote feature that detects whether to charge or to not charge. And so what you do is you send 12 volts back to it, or key switched. You know, it's normally like a key on, that turns your power pack, everything on. If we hooked it up just straight to the battery, then, or like I'm talking about, not use that feature, it would not know when to charge and when not to charge. So what you do is run the key on, switched on, back to that, and then it knows, okay, I'm ready to start charging. And it detects when the engine is running, like it's on, because it'll start seeing that pulse from the engine, you know, that's coming out of your rectifier. So what we're going to need to do is we're going to come straight off of our rectifier, and that's going to feed the input. It's the input of our DC to DC converter. And then I figured out that right here we've got a key switched on. One thing I noticed too, this thing is kind of up against this housing, so I'm gonna fix that. But this is our on, that's just always from the battery, and then this is going to be key switched on. They hooked up this cable, it's a telephone cable, they're going all the way up front so that he can have his cell phone and then his tachometer. So they got a couple different modes, and it's got a Victron Connect app you can use. Right, it's right here. So they show a fuse. That's that 50 amp fuse that I bought. It's going to go up to the input side, which is the engine, right? And then they're showing output as the load. You'll see, like, here's the key, and then you're going to supply 12 volts to the L, and then I guess you're just tagging this to H. So when it sees voltage, even though this is ground, but it'll show you the bulk charge. Anyway, that's why I wanted to get the isolated one, because I wanted to isolate stuff. And you could add batteries, as long as you don't go, you know, you could do, like, you could buy the other one, it's like 12 or 24. So you can add more batteries, and you can daisy chain these. Oh, it also here shows you your gauge wire. So, you know, 10 gauge for us on this will be fine. Thanks for watching. Go ahead and hit up HawkeyeMarine.net if you need anything. Got all kinds of boat parts. Okay, I got the Hub Buddies on. This is a 1.98 inch diameter. And I got that one on that side, and then I got the other one on the other side. I've got these Blue Sea. They're just, you know, they're a fuse block. So it's clear now. You can see if this was blown, you can clearly see it. Once they blow, they're blown and you're not coming back. But we go ahead and fish this through to the Victron side of it. All right, so far so good. Coming out of a rectifier, we're gonna go, this is going to the Victron, excuse me. This will be a ground. I just don't have the connector. I'm gonna have to go get some connectors. We got our signal wire right here, and I use this type of stuff because it's gas and oil resistant, and I'm just routing it around here. And then I use some mesh just to make it look pretty, since this is white, right? So we got our signal and our power ground coming out of the rectifier, so it's not coming off of here. Okay, this would be a battery terminal. Normally out of your rectifier, you tie to the hot for the rectified voltage, but instead we're gonna go, because out of the rectifier normally would feed our signal here that's to our battery, and that just connects to here, and it routes over here up through, you know, fused to here. Okay, so that's just normal routing, and actually it's sending the voltage back to here, so this was just tying into the voltage. Alright, well, it's another nice day in the middle of January here in Middle Tennessee, and I'm out here trying to set up this thing so that you're like, what thing? I'm trying to set up, my customer wants to run a lithium battery on a 1973 outboard, and so almost everybody you'll hear will say you cannot run a lithium, and that's true without having something to talk to the engine, and so the same, you got to put another device in line so that it can regulate the charge that's going to the battery. the battery. So we got this cranking battery. That's another thing. You're gonna need a starting battery because you have to be able to deliver the right amount of pixies to the engine. And then you got to add one of these Victron DC to DC converter, and this is an orion-tr 1212-30 amp charger. It's a DC to DC converter. So I got it hooked up. Couldn't hardly see this light. But it is on finally. So the way you do this, okay, I have key switched on, and that comes here. And what it does is when you turn the key on, it tells it, okay, you can charge. You start charging. So anyway, then we're gonna go out of a battery into the input side of this. And that powers up this device. When I first thought about this, I was thinking, but you're charging the battery. It should be the output. Think of it the other way. This is the load. The output side is the load. And the input side is going to be the battery. And that is going to charge up this device so it's ready to start charging. I have 10 gauge wire, and I could have went to even 12 or whatever gauge this is, but this is 10 gauge. This goes over to that output on the load side, and then I just got a ground wire coming up, so it's got to be grounded to the block, and it's got to have the output side of this. That will protect your stator. We don't want pixies backflowing into the stator, heating up the stator and burning it up. And we don't want pixies coming back into the rectifier and burning it up. We also don't want the voltage to heat this device up so bad that then it burns up your rectifier. So what the isolator does is it isolates the two circuits and equalizes them, if it will. If it doesn't need that voltage, to charge up the battery, then it doesn't use it. It has controllers inside of it that it has the right charging curves. That's what I think anyway. I'm theorizing here. We don't really know. This is the first one I've ever done, so I have no idea if it works or not. We're going to find out though, but I'm pretty sure it does. Now, I bought the isolated one because I wanted to isolate the input from the output, and I think with this you can actually wire this up where you can do 2 batteries. It's a little bitty runabout boat, it's really kind of way overkill. But this is what he wanted, and alright, I guess I'm gonna start this. Dude, I'm gonna get a meter first though. Just to get a meter here, maybe take you with me, I don't know. Tub of water, it's the end of the day. Might be able to just do it like this. See, I've got it all hooked up. It's dark. I'm gonna mount that. You can't see it because it's pretty dark. Hang on. See if I can get my light. So, yeah, I'm gonna mount that guy down there. Maybe tomorrow I'll take the battery inside, but I thought I would hook up this meter and make sure we're charging. 13.44. So we're kind of doing this in the dark, but yeah, 13.44. So it might take a minute to warm up. So it's going to be a cold start. Hopefully everything goes good. So let's set you back here. I think it's a steady voltage. There's no way to know until it so it was at 13.44, it's at 13.4. Lithiums, you know, they stay at the same voltage. So it's not gonna be like a lead acid battery where it goes up and then it goes back down. You know, and you can really tell. This is gonna stay at the same voltage. It's gonna be almost no way to know if this is taking something out of the battery. So I don't know, I'm gonna let it sit here and run for a minute. I don't know how much fuel we got left. Okay, yeah, 13.39 dropped. Eventually, I guess when it drops below a certain, you may have to increase the voltage. This does have an app. I'm gonna see if I can finally Bluetooth to it, or what do I need to do? I may have to revisit this tomorrow or the next day once I get, you know, this thing mounted inside the boat. She's a smoker. Thanks for watching all the way through. You're part of our awesome community. Love this video? Hit subscribe for more adventures. The best way to support us is at hawkeyemarine.net. Shop outboard powerheads, lower units, and top quality boat parts. It fuels our content and keeps you on the water. Visit today. We'll see you next time.